So I'm Jags Ramnarayan and the CTO co-founder for SkySQL. I don't know how many of you know SkySQL before. It's just a division. A year ago, it was a division in MariaDB. So essentially, the MariaDB cloud platform was called SkySQL, launched in 2020, perhaps. It became an independent company roughly about a year ago. MariaDB still has a small stake in the company. I'm going to just briefly spend maybe a slide or two on what SkySQL is and spend most of the time on the AI work we've done. If you're in trouble, okay? But it's time to dazzle, right? So SkySQL, we think it's the most comprehensive managed cloud database for MariaDB. It runs on all the major clouds. It's available on roughly about 40 global regions today. Since we came out, actually, we grew quite a bit. Now we have customers pretty much in all the major geographies in the world. We added all support for major clouds. For instance, HA that almost everybody cares about. We can give you not just availability across zones or data centers. Our customers depend on availability across regions, even across cloud providers. And in some cases, even being able to replicate to their on-prem MariaDB, for instance. So you add a lot of features, right, over time. And I'll talk about that. So the way people consume SkySQL today is primarily using, if you want control, you get your specific instances that they're interested in. You control the size, you control when it runs, you control if you want auto scaling. So that's what most of our customers do. Just very recently, we announced our first serverless offering for MariaDB. And we took a very different path than most of the other guys, where they've taken the storage engine, dissected it out, and re-implemented storage in a separate tier that is multi-tenant. The way we have done it is completely in a cloud-native way. We heavily leverage Kubernetes for everything we do. So essentially, we're using C groups extensively. We do very small micro-resource control for CPU memory, and this based on connection utilization, based on obviously CPU utilization, things like that. So that's working pretty well. Give it a try. Just click a button and you get essentially a database. And we essentially make it free for developers. In fact, it's a perpetually free serverless database. And it currently launches 11.7. So immediately get MariaDB Vector with it. So, and our SkyAI Agents, that's the talk today. So just at 30,000 foot level, sort of how it works. As I said, it's all about orchestrating hundreds of Kubernetes clusters across the globe. Really, that's kind of what we do. And the control plane itself is a split control plane. So we run a chunk of a control plane essentially at the edges, wherever the database is running. And as you'd expect, we have implemented a range of operators and controllers to do anything from auto scaling, auto stopping, controlling where the resources run, delta management, observability, all that runs through extensions for Kubernetes. There are a number of things customers have done. One simple example could be a customer is essentially doing a large data load, and they're noticing that it's just taking time, right? So it's a huge dump of data. The replicas are far behind. And our operators can essentially intervene to say, let me take a quick differential snapshot of my primary, use that to recreate an replica, and all of a sudden, within a few seconds, the replica is up to speed. Likewise, we implemented everything to do with sort of especially servers, right? How do you do essentially using C groups, how do you control container size, the resources allocated? That's been a lot of really aggressive work with Leopard. And as with respect, there is the central control plane that runs essentially in GCP. And that's where we have all the different features, right? Onboarding, provisioning, there's a natively implemented billing engine. We have notification alerts. There are fairly flexible backup services that we implemented since we came out of MariaDB. And of course, there is APIs to control anything with the. So let's talk about SkyAI. How many here are familiar with sort of agentic RAG? RAG, everybody heard, right? So right. Some I'll briefly cover those concepts. So first, with MariaDB, everybody gets SQL interface. Our focus is to really see if we can extend the traditional SQL database to offer text-based conversation semantics. Right? It's a very, very hard problem to solve. But and of course, all sorts of BI vendors, and if you've been watching some of the BI space, whether it is Snowflake, Spartex, or what Google BigQuery is doing, everybody is trying to get into the space of essentially text-to-SQL. Our focus is really, right now at least, operational data, right? So we're more focused on saying, can I give you answers on data that's moving, changing in its real-time nature, and it's highly concurrent. So one way to think about what we're trying to do is to say, like, what, so that you mentioned, right? I have my traditional applications that are very fixed workflows. Can I essentially add that dynamic component to it? Like it's maybe a chatbot, could be internal facing CRM application. We have customers that are looking and saying, can I do sophisticated support, right? I mean, support is really today a big use case for this, but really support on an online system. So those are the types of use cases we're looking at right now. But in the future, we might look at analytics also as we go on. But the truth is that, irrespective, there's just a deluge of sort of text-to-SQL pilots out there, right? There are benchmarks on text-to-SQL, quite a few actually. But the truth is that nothing, in my view, nothing comes close to really working really, really well. So the question is, how do you get to that point? Let me just touch on the few strategies out there, right? The simplest is what probably everybody does, right? Which is to say, hey, can I just take my context? So if you're doing text-to-SQL, what is the context? It's your DDR, right? It's your table definitions, your constraints, maybe a little bit of sample data. And just pass it in, right? Pass it into the LLM every single time you make your user request. In other words, along the prompt goes all your context. Of course, I mean, you immediately run into context length limitations with any LLM out there. Sure, Google has LLMs that are extremely supportive, extremely large context, but it's very time consumer. So you can't really do that. You run into those limitations. You run into hallucinations, right? So essentially, you don't get really accurate answers at all. So the next thing is the mother of all sort of design patterns of 2024, right? The RAG to augmented generation pattern. This actually came out in it's a seminal paper from Facebook in 2020. It's a dense read, but it's really become very, very popular. But the idea is relatively simple, right? You take your metadata, which in this case is all your table definitions, constraints, what have you, and you're essentially indexing it by creating embeddings into any vector store. Then when a user makes a request, you're doing a similarity search on a vector store to just pull up just the content you need, just the context you need. In other words, potentially just give you the top 5 tables, definitions that we think could matter to the exact user request being made. And you take that, and that becomes a context. And obviously, the context will become much smaller. Take the user prompt, send it to the LLM to generate the SQL, right? And then take that SQL, run it on safely and securely on your database, and after completeness. Even that, I mean, from our experience, it's nowhere close to you. You may lucky on real world databases if you get your 30% accuracy in my day, even for relatively simple questions, right? I mean, the truth is that in any real practical database that you have, there are hundreds of tables, the column names are esoteric in nature, the terminology people use don't match to what the schemas tell you. So lots and lots of things that are missing. And not just that, we also find that only the best LLM, right? I mean, you haven't never tried O1, for instance, but GPT-4o or Google's Gemini. I mean, they have even syntactical errors, even though they understand MariaDB syntax and MySQL syntax fairly well, but a ton of errors that have all of it. And ultimately, the accuracy is pretty darn low. So the state of the art is really what people are calling as agents or agentic RAD. And if you, I mean, this is the year of agents is what we call it, right? Especially for SaaS applications. There's a lot of focus around rebuilding SaaS so that they're very agentic in nature. It really comes down to 4 key characteristics or criteria from my standpoint. First and foremost, agents, an autonomous agent, as you call it, is very task and goal oriented. In other words, very specific your task, smaller your task, the more accurate the answers are. The second important thing is that it can reason with complex questions. So think about the agent as a piece of software that's working hand in hand with the LLM to accomplish relatively complex tasks. So it can essentially take your question, decompose it into a series of steps, and essentially execute these steps in some sort of order. And remember, in the world of LLMs, and the key is that we are not deterministic. They're by nature indeterministic, right? So it's like you can think about a control flow. The control flow is essentially dynamic based on the context and what the LLM decides to do. But other nice thing with agents is that we can use tools to take actions. In our case, what do we need? We should generate with SQL. I got to be able to execute the SQL safely in my environment, take the results, and perhaps feed it back to the LLM to take the next step. But the most important thing is the ability to self-reflect. In other words, there could be syntactical errors. I could look at the syntactical errors, and LLMs and the agent will automatically try to rectify those errors. And finally, the ability to synthesize final answers. So it's really good. Okay. So here is a simple example of an agent we have, right? So we have pre-built some agents in SkySQL to make sure you. One of them is what we call as the SkyAI Copilot. So one of the questions it can answer is, okay, analyze the top N slow queries and tell me ways I can optimize it. So we have essentially defined some guidelines for the agent to take. So the guidelines essentially are, here's a slow query logging on. If it's on, is it going to table? Then go and fetch the top 5 slow queries. Typically, when you go into the slow hog and fetch the queries, if I'm executing some other schema, I'm to rewrite the query so that the schema gets prefixed inside the slow query. So essentially, there's a step that I have to rewrite the query itself, then execute each of them with perhaps an explain or explain to the JSON, take those results and use the LLM's prior knowledge of what's MariaDB to produce some sort of answers, right? So in all the steps, as you can see, you're using the LLM to produce the SQL and running the SQL, taking those results, feeding it back to the LLM to say, you decide what the next step is. Right?
One question. Is the LLM smart enough to find those things directly from the slope, or do you need to be more exact description of how to be?
No, we only use the LLM. It generates the SQL only, right?
But this means that you have the slope in a table.
The current implementation is such that we require it to be on the slow log table.
Can you do that explains?
So most of you who have been looking at, traditional Llama indexes, Vortex AI, there is Bedrock from Amazon, on and on, right? There's a deluge of RAG frameworks, Llama Index, LangChain, most popular ones in the open source community-wise. Well, why can't they achieve the exact same thing? And they all, in fact, the agentic frameworks. You can absolutely create agents using these frameworks. And it's, for a lot of the cases, that's the right answer. You want heavy customization. You're perhaps working with large documents. That's the right answer. But for us, given that we need the real-time answers, it becomes really critically important that what goes into the vector store is in fact totally consistent and transactionally consistent with the data you're actually storing in your database. Right? So hence the ability to sort of use MariaDB Vector is absolutely critically crucial. And of course, this staging is really complex. The truth is that with agents, we have concepts of long-term and short-term memory. In other words, the conversation state has to be preserved. So that all could be sensitive data, right? Metadata itself could be sensitive in a number of situations. And you have to deal with different LLM choices. At some point, you might have to deal with LLM tuning itself. So all of those choices are really complex from our standpoint. The question is, can we dramatically simplify an architecture that basically looks from our standpoint similar to the complex? Right. So as the SkyAI Agents comes from the plan, a simple way to look at this is, how do you go from what I showed with agents and RAG, which is presumably the state-of-the-art design today, the generative AI, still bad in performance for this specific problem. The only way to do a better job with it is you have to inject the expert human to look, the guy who understands your data model really, really well. He doesn't have to know coding. The key for us is simplify everything from an automation standpoint. So the way we are introducing AI agents is that it's a no-code way for an expert to introduce the semantics that's missing so that the SQL generated is significantly more accurate. Okay, so that's number one. Number two is the ability to provide determinism. At the end of the day, no matter what you do, doesn't matter which LLM is, we can try DeepSeek also, it's going to have errors. The SQL generator will be problematic. In other words, you could syntactically you could correct, but the answers are in fact wrong. So we have been working on essentially using the LLM itself as a judge to finally figure out whether the answers are in fact correct, right? So we're looking at faithfulness score, we're looking at a confidence of the answer's accuracy. So we have a number of techniques. So the idea behind that is to sort of say, we will avoid giving you false positives, but we might give you false negatives. In other words, I might say that, oh, I don't think the answer is, my confidence is low in terms of the answer, but the answer could be correct. But he'll never tell you, say that the answer is correct or the answer is wrong. So the way it works is we are an opinionated framework. So there isn't all the bells and whistles that are available, Just use the UI and you automate the entire RAG pipeline, right? So you're running the RAG pipeline very close to where your MariaDB server is itself. And you generate the context that I described, which you really need to run through the RAG pipeline using an agent builder UI. And then the domain expert will allow the domain expert, guided way to come in and tune the context of the rules that are missing, adding semantics. Essentially goes through a whole iterative cycle. And then finally, when he thinks that the agent is ready, essentially publishes. At the moment this publishes available as a REST API. And main thing again, like the reproduction is like why MariaDB Vector is at the end of the day, we have to maintain data consistency between what's in the database and the vector store. So the ability to say, well, the vector store somewhere else becomes very challenging for us. And then the online evaluation is something that we think is very distinct and very unique to what we did. So this is just a sort of a high-level view of, what is it that they're trying to do? It's essentially packaging all that complexity so that it looks just like one database service. You just work with it, and off you go to get essentially conversations and marks. All right, so we'll see if I pitch you was here. Okay, this is somewhat similar to what you guys have. You have like you have like 5 minutes, 10 minutes, or like 5. Let's say, okay. So I'm not going to go through. And work. YouTube. And I guess you cannot disconnect. You did couple and you have to see them look and let's see. Yes, you better. Okay, so in just all down to just a quick example of an agent that I've already created. So the idea is that when you essentially get to SkySQL, you deploy a database, you get your data going, and we have built-in agents. So as an example, if you here, you see that there's a developer copilot agent or an EPA copilot. The developer copilot is like ChatGPT++, basically, right? In other words, it's just going to give you answers to MariaDB questions. Obviously, the LLMs have picked up everything on the knowledge base, but they're not really refined. Sometimes they answer wrong. So we've modified the prompts so that the answers are more appropriate. We can generate stored procedure, you can generate SQL, all of what a developer would want to. But the more interesting thing is that DBA Copilot, where we've actually indexed, a whole bunch of information schema tables. We have performance schema tables described. We have all the variables described and all that. So essentially, a DBA can ask relevant questions. All right. So as an example of this, here are the top 5 queries that really slow and analyze the So those are things we're building. Now let's talk about what the users can do, which is they want to create an agent on their data itself, right? So then I'm just taking a very simple example of the Internet GUI database. The rest is too complex, that kind of described. So the way you create agent is you just go click create agent. And the main thing is I'm not going to actually create this cutting multiple minutes. When you have to specify the intent, like what is the task you want me to do? Like I said before, the narrower the task, the better it is. And then once you have the task, we essentially go and index the entire schema, right, into the vector store. We actually take enough samples of the data and we calculate a bunch of things. Right? We compute essentially the semantic description of the table itself. We try to discover relationships in the data. We try to figure out which are the columns that are categorical in nature. So we essentially synthesize autonomously enough context that we can derive just based on the database itself. Then we essentially, once you've done that, we present it to you. So in this case, you cut this agent. Obviously, I don't have to give much here because IMDb is a well-known database. The tables are well named and all that. So I just said, it's inside some movies, actors, directors, and ratings. Once we created the agent, it essentially picked up all these tables that are in green, right? And within each table, if you look, so it has essentially generated this semantic description for the table. It's just, just looking at the data and stuff like that, it's generating that stuff. And then the idea here is that now you can essentially modify, you can add old rules now that are simply missing from the towers discovered to read it. And most often, like you don't never want all the columns, right? And then most times, hundreds and hundreds of columns, nobody just select the columns that you need. And you'll see that one of the other things we can click on semantic index, which is where we essentially take the values of that column. Typically, we would semantically index categorical values, things that will land up in where clause, right? So that's correct. So as an example, if you see here on genre, I've actually semantically indexed genre itself. So let's just quickly try to couple of questions, see what happens, right? So list the top 5 highly rated, movies that Clint Eastwood acted in from the 80s. I never knew that Clint Eastwood acted in fact the feature too, but we did. So as you can see, we always print out the SQL query that we generate, and the results also that are synthesized for events. But as you can see, it looks like a 3 table or 4 table join, what have you, right? But then you can continue the conversation, right? We can say, and this is the real power, right? Because it's very difficult to have the right prompts, user prompts generated. It's very difficult for people to ask the right question. So the ability to continue the conversation is absolutely critical for people to become really productive, right? So you can say, hey, what about, let's say, the 90s? No. Yeah, behind the scenes, we are engaging the RAG pipeline. We are going, when we use OpenAI's GPT-4, 4.0, and as you can see, it does not give the answer. Or for instance, let's say, let's try another question. Let's say, how many cowboy movies were produced in the 80s and 90s? So this is where now you see that the power of using the vector store to do the search really becomes relevant. You see the question I just said, cowboy movies, right? And if you look at the where clause, the genre is actually Western, right? So what has happened here is, behind the scenes, we have actually gone and modified, and just printed this is framework already. Phoenix, it's a way to do traceability and observability and so of the world of LLMs. So it's a very powerful open source grid. We have actually injected a bunch of values that we think are semantically matching the question the user is asking based on everything that they've indexed. And as you can see, essentially it's injected a thing that says genre is equal to Western, even though you insert cowboys. So now the LLM picks up the fact that, maybe the genre should be Western. There is no cowboy. So I'm going to change that where clause to use the Western filter. So that's the power. Yeah, so let me just go back. I'm just going to take a minute. Hopefully that made some sense. This is really the simple view of like what I just showed you. I'm not showing you the runtime architecture at all. This is simply, what do we do, which is in blue. What does the expert human does without any code? He's just absolutely only typing text and correcting things in the UI you guys saw using text. I mean, I did show you one other step that as you go through the process, you're iterating and marking things as golden. In other words, things that were really answered well, we think that this is what the user should typically ask. You keep on creating what we call as the golden SQL. Okay. And the golden SQL gets recorded and becomes part of the context, again, back into the vector store. Everything goes into the vector store. So we kind of always generate this context, like context, and always. And that's how the agent's performance continues to improve over time. All right. So how did we, just one last slide on MariaDB Vector. I mean, like I think, so we mentioned, we implemented the Llama index connector for MariaDB Vector. One of the nice thing that Llama index is that all of a sudden, if you can create complex RAG pipelines, use a whole ecosystem of tools inside the world of agents and LLMs, and only really read this one line, which is also the it showed us. One thing I should, we initially started by using the built-in vector store it's an in-memory vector store that's a Llama index. I believe it's basically just the Facebook files that it's a brute force. This is called flat type DF4 also, which essentially scans everything before returning an answer. Doesn't scale up to that. Switch to Chroma, which is based in SQL and very easy to do. But yeah, the recall was really low at the end of the day. But even with MariaDB Vector, we have to adjust, not N, but we have to actually adjust the exploration factor at the end. Maybe adjusted M2, I'm not sure. The M is really the number of connections any node of the graph makes to other nodes, right? Other potentially similar things. And I don't understand what exploration factor is. I'm assuming how much deep inside the HNSW graphic costs. Sure, but we have to adjust EF factor from, I think a default is a 10 or 20. Where the increase at 40 could actually fit the behavior we were looking for, given these very, very small strings we were indexing. And yeah, given that it's all text-based, cosine similarity distance search is what we depend on. And we use OpenAI embedding, so it's gotten about 50 to 60 chips. So give it a shot, serverless. Go to skysql.com. Promise you 2 clicks and about 3 seconds, you'll have a MariaDB 11 lots of database. Cool. Thank you. Any questions?
How does it actually determine which genre should keep the fish? Does it make some sampling on the data first?
Yes. We do. It depends on which cycle. When you initially create the agent, we just take initially the DDL. I don't know whether we take samples across all the tables. It'd be very expensive. We just take the DDL, and if there are any table comments and things like that, we use that. And then that's when we use that to figure out, say, which tables, give me a subset of tables that we think matches this requirement. After that, we go through a cycle of saying, let's now take samples. Not only that, we're actually looking for every column that we presume is categorical in nature. So we essentially do a constant and actually.
Yes, we do everything that actually analyze procedure. Just do a select procedure analyze. You get the best type for each one, and anything that can be an enum that might be provided enough. You get the most of the data.
Categorical songs.
Yeah, so yeah, look at procedure analyze in the manual. I mean, already that they argue.
Right. So we also look for categorical values, not the keys. Because there's no point indexing those keys.
So it's just assumed. So
this the automatic finds that these equivalent as this very value. And how we do about that? It helps the learn to know that this actually is an anomaly and not strict.